In this problem, we're asked to solve the equations algebraically, write our answers in exact form, and then give decimal approximations rounded to the nearest hundredth. When we are working with a radical equation, in order to solve, the first thing we want to do is make sure that the radical part of the equation is isolated or by itself. So in this case, the radical part is this part right here. It is by itself in this case, and so our next step is to clear the radical. If we clear the radical, what we're going to do is do the opposite of the root. So if I have a cube root, I am going to cube both sides. So raise each side to the third power. So the cube root of a cube just gives what's under the radical. That's how we clear the radical. 2x minus 1 then equals 5 cubed, which is 125. To solve for x, I add 1 to both sides, getting 126 on the right. Dividing both sides by 2, I get x equals 63. Now, it's very, very important that I perform a check. Just because I obtain a solution does not mean it is the correct one, and oftentimes when you are working with radicals, you can introduce what are called extraneous solutions, not usually with a cube root or an odd root, but a lot of times with even roots that can be the case. So let's do a check. So what we're checking is that when we plug in 63 into the left-hand side, that we get 5. So I have the cube root of 2 times 63 minus 1. That is the cube root of 126 minus 1, which is the cube root of 125, and cube root of 125 is 5, which checks. So our solution of x equals 63 is correct. We have found that algebraically, and we have verified. Let's see what happens with part B, which is a little bit different. So the radical part of this equation is this part right here. We want to get that part by itself, isolate that part. So the first thing we're going to need to do is to subtract 41 from both sides. So I end up with 5 times the square root of 2x minus 4 equals negative 30. Again, I want the radical part by itself, so I'm going to divide both sides of the equation by 5, leaving me with square root of 2x minus 4 equals negative 6. Now I'm going to square, which is the opposite of square root. I get 2x minus 4 equals 36. Add 4 to both sides. I get 2x equals 40. Then I'm going to divide both sides by 2, giving me x equals 20. So all looks good. I've obtained the solution. However, I absolutely have to perform a check, because squaring both sides is actually not considered to be an equivalent operation, and we might have introduced an extraneous solution. So let's plug in 20 on the left-hand side and see if we get 11 as a result. So I have 2 times 20 minus 4 underneath the radical. So that gives me 41 plus 5 times the square root of 2 times 20 is 40 minus 4 is 36. I get 41 plus 5 times square root of 36 is 6. That leaves me 41 plus 30, 71, which does not equal 20. Therefore, x equals 20 is called an extraneous solution, meaning there is no solution to the original equation. So be very, very sure when you're working with these radical equations that you check all of your answers at the end.